Okay, my next subject, is the equivalence between the two second laws. Okay, so we saw that there were two formulations of the second law. One was by Clausius, another one was by Kelvin. Okay, can somebody tell me off the top of their head what Clausius's formulation was?
No.
Okay, one person. Okay, I think it was Saif and Nahi, right? Nahi, why did you go?
So one of them was that no thermodynamic process would be possible whose sole result is the transfer of heat from a cooler body to a hotter body. And another is no thermodynamic process is possible whose sole result would be the total extraction of work from the body.
Okay, so there's a lot of background noise, Nahi. I couldn't really figure out what you were saying. Can you repeat it again? Sorry about that.
Okay, sir. So one of the statements is that no thermodynamic process is possible whose sole result would be the transfer of heat from a cooler body to a hotter body.
Okay, good. Yeah, awesome. That is Clausius. Okay, somebody else tell me Kelvin. Not Saif, somebody else. Nafiz, yes, you tell me.
Sir, Kelvin says something like the no process is possible, the no conversion process possible between heat into work. So that means there's no process possible whose sole purpose is to actually convert heat into work.
Right. Yeah. So you always have to have some waste, right? So if you take some work and you'd want to transfer them to heat, you cannot do that completely, right? Yeah. Good. Very good. Okay. So let me show you how uh, the violation of Kelvin leads to a violation of Clausius. Okay, and I will leave it as an exercise for you to figure out the other way around. Okay, so you need both to Clausius. Sorry, I always write an extra S. Clausius. All right. Okay, so it goes something like this. Suppose that you have a reservoir TH, hot reservoir, and a cold reservoir TC, and you're assuming that Kelvin is violated. So this is Kelvin violating engine. So what it does is that it takes some amount of heat, say QH prime, and turns the whole thing into work. It doesn't have to. It doesn't waste anything. Now this work is running a Carnot engine in reverse. Okay, and so it's we know that Carnot engine in reverse means that it can draw some amount of heat from a colder reservoir and dump a bigger amount of heat. And dump another amount of heat into the hotter reservoir, right? So according to the Kelvin violator, this heat is equal to work. And according to our Carnot engine, the work is, QH has to be greater because the work is positive. So QH is the heat dumped into the hotter reservoir, and QC is the heat that is absorbed from the colder reservoir, because this is the Carnot engine is running in reverse. So what we can do is that we can rewrite the second equation as QH equal to work plus QC, right? And then we know that QC is the work is equal to QH prime, which is the heat that is absorbed by the Kelvin violator, right? So now what we can say is QH minus QH prime is QC, but QC is a positive quantity. So therefore, now if I now say consider these two guys together to be the same engine, then we see that together this guy brings in the heat QC. It takes in QC from a cold reservoir, and it dumps the heat QH. And it dumps the heat QH minus QH prime into the hotter reservoir, right? So the net effect of these two guys is to transfer heat from the colder reservoir to the hotter reservoir without any other effect, right? And therefore, if Kelvin's law is violated, so is Clausius's law, okay? So any questions?
Sir, I had one in the back chat.
What does it mean to consider two engines together? Okay, yeah, well, you can basically write that this is equivalent to, some machine, right? Where this is QC, and this is TC, and this is TH. Now, here, this is it's absorbing heat QH prime, and it's giving out heat Q of H. And here we've shown that QH is greater than QH prime. So the net effect is that it's giving out heat, giving up heat into the hotter reservoir. So the net effect is that it's this machine is absorbing heat from a colder thing and then dumping the same amount of heat, because as we saw, QC is equal to QH minus QH prime into the hotter reservoir, right? Which is, Clausius says that cannot be done.
Oh,
okay.
Yes, sir.
All right, good, awesome. All right, so we have shown that how violating Kelvin violates Clausius, and I leave it for you as an exercise to show that violating Clausius leads to violating Kelvin. It's actually easier to show.